Today we're going to start out with kind of a confusing topic, and that is sequences. It is sequences because sequences have a lot of stuff going on in them that it's hard to start at the beginning because the beginning really is the end, and that's what they are and formulas for them. So today we're going to throw a lot at you, and then we're going to break stuff down a little more simplistically starting tomorrow and then Monday. But today we're just going to scattershot what a sequence is and some important information about it. Well, a sequence at its heart is nothing complicated. It is just a sequence of numbers. As in, we could have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's a sequence of numbers that you know which one the next one would be, and I could ask you which one the previous one would be. So I can ask you what would come before 4, and that would be 3. And it'd be 2. Sequence can go on forever, or they can stop at a specific. So I could just say, we're done. That's your entire sequence. Or I could say, it's going to continue forever. So at the heart, that's all a sequence is. It's a pattern of numbers that we can recognize what the next would be, and what the next would be, and where the beginning and end would be. Now, with a sequence, if we were just doing regular English, I would just say the first number is 4. The second number is 5. The third number is 6. To make it a little more mathy, we use the word term. So we can use the word term. In this case, 4 would be your first term. 5 would be your second term. 6 would be your third term. But terms kind of break down when we start going in the opposite direction, because there could be a number here. And in fact, we know what that number would be. It'd be 3. But saying something like the 0th term and the negative first term kind of breaks down in our notion of first, second, third, first, because first is first. There's nothing before it. So with sequences, we use something called A sub n. A sub n takes the place of saying first term, second term, third term. A sub n tells you what position in your sequence you're talking about. So if I say this is my first term, rather than saying my first term, we are going to denote that as A sub 1. A sub 1 just means it's the first term in that sequence. So my second one would be A sub 2. Then we'd have A sub 3. And then we would have A sub 4. And let's say we go way out past 9, and I don't know what to call it. We'd call it A sub n. That is some mystery. I don't know where it is in the location. Now, the key about having A sub 1, A sub 2, A sub 3, and A sub 4 is there really isn't a first, second, third. It looks like A sub 1 is our first term, and it almost always is. But there are times where my first term will be A sub 2. I'll say use the sequence starting at 5. And 5 is A sub 2. We just know these A subs just tell you where they are in the sequence. So I could give you an A sub 0, and you know it's the term before A sub 1. I could give you A sub negative 1, and you know it's before 0. So this gives you an order, but it's not specifically where A sub 1 is your very first number that you write. It just gives you a placement of everything. And that's why we have, if A sub n is a term, then A sub n minus 1 is 1 to the left of it. So it's 1 previous. That's all A sub n minus 1 means. It means it's 1 previous. So A sub n minus 1 is the previous term. A sub n minus 3 is 3 terms previous. And finally, A sub n plus 5 is 5 terms after. So we're going to do a very quick example right down below it to show you what I mean. Let's say we have A sub n. But I tell you n equals 5. So if I say let n equal, that says ne, and let n equal 5, that means a sub n would equal a sub 5. And in this case, I'd find kind of my fifth thing, so that would be 8. So if I ask you to find a sub n minus 1, all I'm asking you to do is, our n equals 5, so I'm asking you to find a sub 5 minus 1, which equals a sub 4. But like I said, starting off, I was looking at my fifth term. N minus 1 is the previous term, so my previous term should be my fourth term. If I'm at 5, my one previous is 4. If I go 3 terms previous, we would have a sub 5 minus 3, which would equal a sub 2. If I'm at my fifth term and I tell you to move 3 terms previously, you're at your second term. Finally, 5 terms after, you just add 5 to it, so we'd have a sub 5 plus 5, which equals a sub 10. 5 terms after my fifth term would be my 10th term in that sequence. All right, so that's how that sub notation works. Sequences can be finite or infinite. To make it infinite, it would look something like this. We would let our n be greater than or equal to, 1. That means you're going to start at 1 and you're going to go on forever, counting your n's. A finite sequence would look more like this. We would let 1 be less than or equal to n is less than or equal to 5. In fact, if I let n be somewhere between 1 and 5, I would be looking at a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, so I'd stop at that 8 in this sequence. I would just write down 4, 5, 6, 7, 8, and I would be done. If I let n be greater than or equal to 1, I'd have to write it as is, because my n's would just keep getting bigger and bigger and bigger and bigger. All right, that is, at its heart, what a sequence is and how we denote it. Let's see some examples of that, though. So we have 2 ways to write a sequence. We have something called a recursive, and we have something called an explicit formula. You have already used explicit formulas almost every day in algebra. An explicit formula, which is right here, is kind of like y equals 3x. You could plug a number in, and you can figure out that answer. Recursive is kind of that new logic with sequences. And that is a sequence in which you're based upon a previous term. It is based upon a previous term. So a recursive sequence is kind of like, I'm going to give you 2. Now keep adding 2 to that. So you'd go 2, 4, 6, 8, 10, 12. However, in order to have a recursive, you have to have a starting off point. Because if I say we have a sequence where we just keep adding 3 to it, Sam, what is that sequence I'm thinking of that I keep adding 3 to it? Give me the first 3 digits in it. If I just keep adding 3 to a number.
Plus 3.
Maybe plus 3, but give me 3 numbers that fit that sequence.
3, 6, 9.
I was going to start at 12. I'm sorry. So for recursive, you have to know your first thing. Otherwise, you don't know what the sequence is. So for a recursive formula, you have to know what the first one is, and that's what we have here. We have our first term is -2. You have to have that. So you have to have your first term listed. And that's what we have here. We have our first term. Then the next thing tells us what we're supposed to do with that first term. So let's look at that. We have a sub n. That equals n plus a sub n minus 1. Well, if I start with n, and I'm at a sub n minus 1, that just tells me the previous term. It says whatever term I want is going to equal whatever this n value is plus whatever the term before it was. So in this exact example, it says write the first 5 terms. Well, they gave us the first term, so we're going to go ahead and write that down. We're going to say, nope. We are going to say a sub 1 equals -2. That's my first term. I just have to list the next 4. I want to note that if I have a sub 1, that means I'm replacing this n with 1. So in fact, for this one, we would know n equals 1. Now we're going to go a sub 2. Well, if I'm replacing that n with 2, we are now have n equals 2. Which means I'm going to replace all of the n's with 2. So I'm supposed to do n plus a sub n minus 1. So instead of the n's, I'm going to put a 2. So we're going to have 2 plus a sub 2 minus 1. Well, that's going to be 2 plus a sub 1. But like I said, this should be the term before it. A sub 1 is negative 2, so I'm going to put that negative 2 in place of that a sub 1. So we're going to have 2 plus a negative 2, which equals 0. For a sub 3, we're just going to replace the n's with 3. So we're going to have 3 plus a sub 3 minus 1, which is going to be 3 plus a sub 2, but a sub 2 is just the term right above it, so it's 3 plus 0, which equals 3. Our next one is a sub 4, so we're going to have 4 plus, and remember, once you get the hang of this, you can just follow the pattern. It is 4 plus the term before it, so it's just going to be 4 plus 3, which equals 7. Then a sub 5 is going to be 5 plus the term before it, which is 7, so that's just going to equal 12. So if you know what this means in plain English, you can almost just do the steps in your head. Go, okay, it's just wherever this n is plus the term before it. So a sub 3 is going to be 3 plus whatever came before it, which was that 0. Our next one says write the first 5 terms, but they gave us the first 2. They gave us a sub 1 equals negative 1, a sub 2 equals 1. So I just have to do the next 3. Whenever they give you 2 terms, usually you have to use both of them in the formula. So if we look here, we have a sub n minus 2 plus 3 times a sub n minus 1. It's not written like this, but you need to see it as this. You need to see it as a sub n equals a sub n minus 2 plus 3 times a sub n minus 1. So this is the term I want. This is the term I want, a sub n. What would a sub n minus 2 be then? If this is the term I want, what do I have to do to get a sub n minus 2? Yeah.
So if we're trying to find a sub 3, you're going to want to put in like a sub 2 minus 2 and then a sub 2 minus 1.
If we're doing a sub 3?
Yeah, if you're doing a sub 3, you put in 3 for all that.
You would put 3 for all that. So it'd be 3 minus 2, which would be 1. How many terms before would a sub 1 be? If I'm at 3, how many terms before would I go? I'd go 2 terms before. This minus 2 just means 2 terms before. That's all that means is 2 terms before. And that n minus 1 means 1 term before. I mean, we're going to see that when we plug in our numbers, but it's good to just know the term I want equals 2 terms before it plus 3 times whatever the term before it was. Well, let's just do the math behind it. So a sub 3, just like Liv said, we'd have to replace all our n's with it. So that'd be a sub 3 minus 2 plus 3 times a sub 3 minus 1. Well, that's going to be a sub 1 plus 3 times a sub 2. Well, I know what this value equals. That equals a negative 1. I know what value a sub 2 equals. That equals 1. So this is going to equal a negative 1 plus 3 times 1. Kind of ran out of room, but that'd be 3 minus 1, which equals 2. A sub 4, so what we did here is A sub 3 equaled negative 1 plus 3 times 1. A sub 4 should be 2 terms before it, which is 1, plus 3 times the term before it, which is that. Let's make sure that works. So when I plug 4 in for my n's, I'm going to have A sub 4 minus 2, which would be A sub 2. Plus 3 times A sub 4 minus 1, which is A sub 3. Well, 2 terms before is 1, plus 3 times 2 equals 7. A sub 5 would be A sub 5 minus 2, which is A sub 3, plus 3 times A sub n minus 1. 5 minus 1 is 4, so that would be A sub 4, is going to equal 2 terms before it, which is 2, plus 3 times the term before that one, which is 7. 21 plus 2 equals 23. These really are as much work as you need to do. Some of us will need to write this step out every single time. Some of us might be able to just see it in plain English. It's how good you are at sequences and noticing the patterns. Like for me, I would have been able to go, okay, this is the 2 terms before, plus 3 times 1 term before. So in this one, 2 terms before is a negative 1. I would see it's negative 1 plus 3 times 1. You can sometimes just see that pattern with how it's written out. It is how much work you're willing to put in homework and how much time you're willing to try these without just muddling through as quick as possible will be how successful you are at these. It really is repetition and recognizing patterns. And if you skirt the homework and just use answer keys, you're going to do terrible in a section. It's just going to happen. All right. So we handled the first thing. Now we're going to talk about the explicit formula. Explicit formula is not dependent on any one before it. So let's look here real quick. If I asked you to find the 100th term of this, you would have to write every single one of these out. An explicit formula is not based upon any before it. It is just a flat out basic equation where if I say I want the 100th term, you'd plug in 100 and you'd get that answer out. So that's exactly what we have here. We have A sub n equals n squared plus 1. It is not based upon any term before it. We know that because we don't have like an A sub n minus 1 on the other side. We just have a strict thing where we have to replace the n's with a specific value. So the first 3 terms of the one on the left would be A sub 1 is my first term. I replace all my n's with 1, so we're going to have 1 squared plus 1, right? Because that's 1, our n equals 1. 1 squared plus 1 just equals 2. A sub 2, our n is now 2. So we're just going to do 2 squared plus 1, which equals 5. And finally, our A sub 3, our n would equal 3. And we would have 3 squared plus 1 is 9 plus 1, which is 10. So explicit formulas are pretty easy to use compared to a recursive formula. Our next one comes to a very huge point, so don't skip this information. Do you see that negative 1 to the n minus 1? You're going to see that a lot. That is because all that does is alternate between positive and negatives. It is the only way in an explicit formula to show that you are alternating between negatives and positive. And that's because negative 1 to the first power is negative 1. Negative 1 to the second power is a positive 1. Negative 1 to the third power is negative. Fourth power is positive. Fifth power negative. Sixth power positive. So it just flips back and forth. You have to recognize this. This is going to show up so much, and we're going to keep talking about it. But the quicker you understand that this just alternates, between this one, in fact, would be positive and negative. The easier life is going to be. You'll also see this as negative 1 to the nth power. You'll also see it as negative 1 to the n minus 2 power or plus 2 power. Your only goal is to plug in your first thing to see if it's negative or positive. So if you plug in your first term as negative, the next one is going to be positive, and then negative and positive. So in this case, that's our big thing. The other thing I want to note is this n has to be bigger than or equal to 2. That means my first term will not be a sub 1. In fact, this one's going to be a sub 2. It tells you to start at a sub 2. That will lead me to negative 1 to the 2 minus 1 times 2 plus 1. Well, that's going to be negative 1 to the first power, so that's going to be a negative 1 times 3. Well, that's just a negative 3. Then we go to a sub 3. I have negative 1 to the 3 minus 1 times 3 plus 1. That'll be negative 1 to the second power, so that's going to be a positive 1 times 4, which is just going to be a positive 4. A sub 5 is negative 1 to the 5 minus 1. Ooh, why did I skip to 5? We should be 4. I don't know why I'm going all the way to 5. We should go a sub 4 first. Is going to be a negative 1 to the 4 minus 1. 4 plus 1. I already know the pattern is negative, positive, so this one has to be negative. And in fact, negative 1 to the third power is a negative 1 times 5, so that is a negative 5. So this one goes negative, positive, negative, positive, negative, positive. Once you know the negative positives, you can forget about your negative 1 to any power. All right, that is an explicit formula, and it also has the alternating between positive and negatives in it, which is going to show up in almost every single lesson we do. All right, the next thing we're going to do is coming up with how to write explicit formulas. Explicit formulas are the hardest to write. In general, yeah. Well, we're going to pick kind of a hard way to do it. We'll talk about why we're doing it, and then tomorrow we'll find what makes it true. So the first formula we have to find is one that emulates 6, 8, 10, 12. That means when I plug a 1 into it, I better get a 6. When I plug a 2 into it, I better get 8, 3, 10, and 4, 12. After that, we just assume it's going to keep that pattern up. So what we're going to do very early, we won't do this again, is to break it down what's happening. So our first number is 6. Our next number is 8. But I want to break 8 down. I'm going to break 8 down in terms of our first number. So 8 is realistically 6 plus 2. Our next number is 10, but that's really just 6 plus 4. And 12 is going to be 6 plus 6. So going back up to 6, that is 6 plus 0. So now we're seeing another pattern develop. We have 0, 2, 4, 6. Not quite enough for an equation, but it gets us there. In fact, I'm going to now talk about things in terms of 2's, because every one of these has some kind of 2 in it. So rather than writing 6 plus 2, I'm going to write 6 plus 2 times 1. Which should make our first one 6 plus 2 times 0. Which should make 6 plus 4 6 plus 2 times 2. And finally, we'll have 6 plus 2 times 3. Now we have the most simplistic pattern there is. 0, 1, 2, 3, 4, 5. And more importantly, I can relate it to what term it is. On my first term, I'm multiplying by 0. second term by 1, third term 2, fourth term 3, fifth term 4, sixth term 5. My 100th term would be multiplying by 99. So if I know how to get to the 100th term, that must mean I know an equation. There is an equation built into all of these. And this equation is going to be, for this one, we are going to have a sub n is going to equal 6 plus 2 times, because all these have 6 plus 2. Now, if my first term is n, so let's go ahead and mark that above these actually. So this is my a sub 1, this is my a sub 2, this is my a sub 3, this is my a sub 4. So when my n equals 1, I need to multiply by 0. When my n is 2 by 1, 3 by 2, 4 by 3, so I'm just subtracting 1 from whatever my n value is. So this is going to be n minus 1. It's always a good idea to check it. So I said my third term should be 10, so when I replace all those n's with 3, I should get 10 out. So 3 minus 1 is 2. 2 times 4, or 2 times 2 is 4, plus 6 is 10. If I plug a 4 in for this n, 4 minus 1 is 3. 3 times 2 is 6. 6 plus 6 is 12. That is, in fact, my formula. But more importantly, my first term is 6. That's right there. Do you see this 2 we're multiplying by over and over and over? That is right there. And I'm going to go one step further. How do I get from 6 to 8, 8 to 10, and 10 to 12? What are we doing at every stage of those? What do I have to do to get to the next one? I'm at 12. What do I do to the next one? Yeah. I add 2. I add 2. The common difference is 2 between that. So I'm going to use what we learned here, and I'm going to try to apply it to here. More specifically, I'm going to look at how I get from 7 to 13, which is add 6. From 13 to 19, I add 6. From 19 to 25, I add 6. So it has a common difference of 6. Well, that's what that 2 was in the last one. That 2 was my common difference between the two. So we have a difference of a positive 6. We also have a first term being 7. No, this 6 was my first term. My common difference was here. And then we had n minus 1. So let's put those two in the exact same order we did on the other one. So we're going to do a sub n equals that first term 7 plus that common difference times n minus 1. And let's see if it actually works still. So I'm going to check my third term. My third term is supposed to be 19. So when I plug in 3, I'm supposed to get out 19. 3 minus 1 is 2. 2 times 6 is 12, plus 7 is 19. My fourth term is supposed to be 25. 4 minus 1 is 3. 3 times 6 is 18. 18 plus 7 is 25. That is, in fact, my explicit formula for that. So that explicit formula will work for any time you see a pattern where you're just adding the same number over and over and over. And we'll talk more about that tomorrow. But in the homework, if you see something being added over and over and over, that's what you need to do to come up with your explicit formula. All right, our next one is not adding the same number over and over and over. In fact, it's a completely different pattern. If you look at the bottom, we have 4, 9, and 16. And in fact, we have 1 over 1. 4, 9, and 16 are very important numbers in the math world. They are perfect squares because you can take the square root of them. So rather than looking at 4, I'm actually looking at 2 squared. For 3, we should picture 3 squared. For 16, I should picture 4 squared. 1 over 1 is 1 over 1 squared. Well, that's not too hard to come up with an explicit formula. A sub 1 equals 1 over 1 squared. A sub 2 equals 1 over 2 squared. A sub 3 is 1 over 3 squared. Whatever our n term is, we're just going to square it and we'll have our answer. Here's the problem. It's alternating between positive and negative. Yes?
So that's when you use like the -1.
That's when you use your -1 to either the n minus 1, n plus 1, and until you get good at it, it's just going to be a guess and check. We need our first term to be positive, correct? We need our first term to be positive. That means when I plug a 1 in for my n, I need to have a positive 1 pop out. All right, so that is the thought. So first of all, it alternates between positive and negative. So we are going to use, and generally the two that I use all the time are going to be -1 to the nth or -1 to the n minus 1 or plus 1. It really doesn't matter. Those are your two major ones that you're going to try using. All right, so real quick, a sub 1 needs to be positive. If I did a sub 1 equals -1 to the first power, that would be negative. So that's not going to work. If I did a sub 1 and that equaled -1 to the n minus 1, that would be -1 to the 0th power. That would be a positive 1. That's the one you want for this equation. So we know for a fact we want a sub n equals -1 to the n minus 1 out front, so I can tackle that positive and negative. And then we're just going to multiply that by 1 over whatever my n is squared. When my n is 1, I'm going to have 1 minus 1, which will give me a positive, and I'll have 1 over 1 squared. If I want to find my third term, that'd be a sub n equals 3 minus 1. So -1 squared will be positive, all over 1 over 3 squared, which is 9. So it's always a good idea just to check to make sure it works once you pick it. You can also throw this -1 to the negative n minus 1 up top as well. Yes?
Can you say n plus 1 instead of n?
You could say n plus 1. You could also say n plus 3, n plus 7, n plus... yeah. You can just keep going with it. I typically use n or n minus 1. It's just my system. But if you use n plus 1 and n, it works too. N plus 2, n plus 3. You just got to make sure that your first one matches. The rest will as well.
All right.
Liv?
It's okay. I got it now.
You sure?
Yes.
Okay. It's important to realize that these are just arbitrarily picked. I just know one of these will be positive first and one of these will be negative because they're one after another. All right, we're going to skip the next one for right now. We're just going to go right into factorials to make sure we get those done. Here's the big thing about factorials because we're going to get to n factorials. I'm sure we've all seen factorials. If I go 9 factorial, you're going to do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Do we all remember those? The big thing to take away from those factorials is when you multiply a number, you multiply the next one by 1 less. Then 1 less. Then 1 less, and that's going to be important right here. Also, I want to note 0 factorial equals 1. That is just something you need to know because it's not something that is figure-outable, I guess. All right, so 0 factorial is 1. All right, we're going to go to the right-hand side real quick. So we have 8 factorial divided by 2 factorial times 6 factorial. You would not take your calculator out for this problem. We're going to do it the long way first, and that is the fact that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 6 factorial, so you're multiplying by 6 times 5 times 4 times 3 times 2 times 1. All right. Let's look at this 6 times 5 times 4 times 3 times 1. Do we all agree that that's going to come out to the exact same answer as that 6 times 5 times 4 times 3 times 2 times 1? I don't care how many times you plug that in a calculator, both those are going to be the exact same. And from where I come from, a number divided by itself just equals 1. So that will cancel out. And you could cancel out little elements as well to help you if you want to. We can look at that 2 and that 8. That 2 and that 8. Well, 2 goes into 8 4 times, so we can cancel those out and just leave ourselves with 4 on top. So now all I have to do is 4 times 7 and divide that by 1. Well, 4 times 7 is 28, divided by 1 is just 28. Well, here's something I want you to recognize from that 8 factorial. This is important with writing it. 8 factorial is really 8 times 7 times 6 factorial. Don't believe me? What is 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. So 8 factorial can be rewritten as 8 times 6 times 8 times 7 times 6 factorial. It can be rewritten as 8 times 7 factorial. It can be written as 8 times 7 times 6 times 5 factorial. You can stop wherever you want and put a factorial symbol. Why we would do that is if we look at the second one, I don't want to write all of 6 factorial out. So instead, I'm going to write 2 factorial on top. And I'm going to rewrite 6 factorial 6 times 5 factorial. Down below, I'm going to rewrite 3 as 3 times 2 factorial. And I'm just going to write 5 factorial. By stopping at the top at what matches on the bottom makes it really easy to cancel stuff out without having to write everything out. Now we can look at that 5 factorial and say, well, that cancels out with this 5 factorial. This 2 factorial cancels out with this 2 factorial. Then all I'm left with is 6 divided by 3, which equals 2. You have to know how to do these by hand because there will be problems that say you cannot use your calculator and you'll have these giant factorials. The other reason why you have to know that is to solve a problem like this. All right, we got to really put our thinking caps on this one. Yes?
Where do you get the 3 times 2 factorial on the bottom?
Because 3 factorial is just 3 times 2 times 1.
Oh.
So I just stopped at the 2 factorial just so you can actually see it canceling out. You could have written as 3 times 2, and then 2 is just 2 times 1, right? You saw it cancel out. I just wanted to have another example of where you can just stop at the factorial. We have to use this fact right here. I have n plus 1. I have n plus 1. To get to my next step of the multiplication, I have to be 1 less than n plus 1. That means I would subtract 1 away from n plus 1, which leaves us with just n. In other words, let's put real numbers with this. Let me say that n is 10. That would make this top one 11, right? My next one would be 10, or just what my n was. It is always subtract 1, subtract 1, subtract 1. So rather than writing n plus 1 factorial, I'm going to rewrite this as n plus 1 times 1 less. N plus 1 minus 1 is just n. Our next one would be n minus 1. Our next one would be n minus 2, n minus 3, n minus 4, n minus 6. In fact, that's exactly what we have up here. Well, that means this is just n plus 1 times n factorial. which is exactly what we have down here, which means our n factorials can just cancel out, and we left with n plus 1. Liv.
I'm just a little confused on how you got the n factorial numerator.
Oh, okay. So maybe we'll do a little scratch work underneath it. I'll do this. So if I'm doing all of n plus 1, I'm doing the whole factorial. Our next step would be n plus 1 minus 1, right? Do you agree that's 1 less?
Yes.
Well, what's 1 minus 1? 0. So what am I left with there? I'm just left with n, right?
Oh, yeah.
Yeah. So would you agree our next one would be n plus 1 minus 2 then, right?
Yeah.
So let me go down. This would be n times this would be n minus 1 if I simplify this one.
Yeah.
Right? What would my next one be with just following that pattern?
N minus 2.
N minus 2. And then it'd be
N minus 3.
n minus 3. Well, n times n minus 1 times n minus 2 times n minus 3 is just n factorial. It is just n factorial. That's why you really have to understand what factorials are to do a problem like this. So my advice to you is just do some scratch work off to the side like this and see what matches up and what could cancel out. Because you could actually do all that work and see it cancels out. Because I could write n factorial out and all of a sudden realize, oh, they're the exact same thing and cancel it out later. All right, real quick. We're going to start this one. We probably won't get through all of them. We're supposed to list the first 4 terms. Our first 4 terms would be a sub 1 equals, I'm going to pull that negative 1 over n out front because I know it's just alternating between positive and negative. So I'll have negative 1 to the first times 1 over 1 minus 1 factorial. Well, negative 1 to the first is just negative 1. So I'm just going to pull a negative. And then we'll have 1 over 0 factorial, which just equals negative 1 over 1, which is just negative 1. If I have a sub 2, we'll have negative 1 squared times 1 over 2 minus 1 factorial, which equals, well, negative 1 squared is positive, so we'll have a positive out front. And then we'll have 1 over 2 minus 1 is just 1 factorial. And that's just going to be a positive 1. Continuing on, we'd have a sub 3 would be a negative 1 cubed times 1 over 3 minus 1 factorial, which is going to equal negative 1 cubed is negative. And that'd be 1 over 2 factorial, which is just going to equal a negative 1/2. And you can continue on by plugging a 4 in, by plugging a 5 in. The big thing is with this out front, I would stop using it. I would just go, okay, the next one needs to be positive. Next one needs to be negative. Next one needs to be positive. The next one needs to be negative. Real quick, if you look at your number 3, 4, and 5, 3, 4, and 5 say, find all the terms of each finite sequence. And then it says 1 is less than n is less than 7 and equal to. So you are going to have an a sub 1, which would equal 1 squared. You would have an a sub 2, an a sub 3, an a sub 4, a sub 5, a sub 6, and a sub 7, and then you'll be done. I.e. a sub 7 would equal 7 squared. So it tells you where to start and where to end your sequence. All right, guys, answer key is online. Like I said, the harder you try on this stuff, the more you